Okay, just going to do a little walkthrough of the optimizer. So when you first open it, this little button right here is kind of important. I like to just turn this off, and it just, when this button's off, it'll only analyze the current loudness type. So it just saves a lot of time if you already know which loudness type you're going to use. Otherwise, it just takes a little longer to process. So I'll drag a file on here. And immediately what you see here is this is all the measurements throughout your file of the momentary loudness plotted as a histogram. So, like right here towards the center where it's the thickest, this is where the bulk of the loudness is basically. So this is sort of would tend to correlate to your integrated loudness. And then you can see how much variation there is throughout the track, how much the momentary loudness changes. It's a little bit like a frequency spectrum, except instead of frequencies, it's loudness. So it's just a different way of looking at your loudness throughout the file. And by default, it just automatically selects the LRA region. And that's just standard measurement that's related to LUFS that just kind of automatically selects a reasonable range for you. So it trims out the bottom 10% quietest sections and then the top 5% loudest sections. It just tends to be pretty reliable. It's just a good place to start. But you can tweak this. When you go all the way up to 100%, it might jump like this. And that's just because somewhere throughout the file, there's some transient spike of loudness causing it. You can't even see it in the histogram because it's probably one measurement. It's just too small to see it. So that's one thing LRA takes care of, is it usually gets rid of that kind of noise. But you can tweak it however you want. I like to just get started with getting these shapes to somewhat match, because this side is going to be what your target histogram looks like. So this the goal of the optimizer is to take this shape and map it over to this shape. So if you want your loudness to tend to be a little bit more top heavy, you can shape the skew, and that will tend to push, it'll sort of upwardly compress these quieter sections to be a little bit louder. Or you could go more the other direction. And the idea is that you're not, usually when you're compressing something, you're not looking at it through the whole file like this, so it's a little unfamiliar. Takes a little getting used to. But the optimizer will then, throughout the entire audio, compress a little bit here and there, expand here and there. It'll do whatever minimum changes are needed to get the shape overall to match the shape that you set. And it's very efficient at doing that because it will take the nearest measurement and shift it just a tiny bit up or down. And that's all throughout the file, and it's kind of aggregates. And yeah, it ends up being somewhat, it's a more efficient in a way because it doesn't have to do as much. It does a lot of tiny changes instead of a few really major changes. All right, so anyway, once you have some basic shape that you think you want to target, you can move on. I mean, you don't actually even have to do any shaping on this page. You can just go on to the next page. It doesn't really matter. The main thing was to set these source percentages. So that's why you have to click the optimize button, is because the algorithm to do all of this mapping needs to know what percentage you actually want to process first before you can move on. So that's the only reason there's a separate step here. And so now once you move on to the next stage, you can actually start playing back the file. And when you play back, it will actually be applying this loudness shape to it. So it's just a real-time preview. But before I Yeah, before I do that, I like to just kind of switch over immediately to some target range. Usually you have some, if you're mastering for some particular scenario. This just kind of helps get it into the ballpark of where you want to go. And if you don't have a specific target like this, you don't need to use this. You can just adjust these loudness values or drag the slider up and down. The skew is pretty important because, again, you can reshape it how you want. But if all you really want to do is just set a specific target loudness, then get the shapes somewhat lined up and then try to line up the center to whatever your target loudness is. So if it's like -20, you can shift it. I forgot I changed this to auto range. Sometimes it's helpful to switch it to a standard reference so that when you're moving the range up and down, it's there you have more consistent numbers on the axes over here. So that's the basic idea. So that it's almost, once you get over the basics of it, it's almost too easy because there's not much to explain. You basically just tell it what you want the loudness dynamic range to look like. But that's not the usual way that you work with a compressor. Usually you're not used to like just telling it exactly what your goal is. You're just like twiddling the threshold and ratio until it tends to hit whatever your goal is. This is just very direct. You're literally telling it what loudness range. So when you're doing a playback preview, it'll start showing what the actual output histograms looks like. And I'm gonna have to mute my microphone to get that to. I'll just play this back and start. You can see what the output histogram looks like. So you can see it was filling in the histogram, and the pattern clearly was representing the same shape overall. And if you played the whole file back, it would tend to, it would converge towards the shape over time. And if it doesn't converge towards that shape, that's usually because you have a lot of really drastic loudness changes, and the attack and release might not be fast enough. So you can kind of tweak those while you're playing back, and obviously by ear, what sounds right. But yeah, that's the basic idea. And again, since I locked in this one loudness type, I can't switch between these without going through and re-optimizing. But had I left that option enabled, then you could switch between them. So if I try to switch a preset right now, it's going to end up invalidating the optimization. It's going to reset back out to the beginning. And the main reason it takes a long time, actually it didn't take long at all. It usually, oh, I didn't, there we go. Yeah, so it takes longer, obviously, because it's going through each different loudness type, plus it has to do channel length and channel split. And speaking of channel length, I think this is one of the best features here. So if you enable, or if you use disable channel length, so you have a channel split processing, these two channels in the original file were really asymmetric. So the left channel clearly quieter than the right channel. So I don't know, microphone placement or whatever it was that caused that. And just right out the bat, this is just implicitly fixed by the optimizer. because it's processing these two histograms separately. And since you have your target range set, it's going to map, it's automatically going to fix that offset for all these individual loudness measurements. So you just for free get an alignment tool out of the optimizer. It's just it wasn't like really purposefully designed to do that. It's just a side effect of the way it works. So I'll play this back and bypass it a couple times. So you can probably tell, obviously, it lifted the level up significantly because it was pretty quiet to begin with. But you probably could also notice that the channels were becoming more balanced when it was playing back, when I had a bypass off. And okay, I guess the other thing is the limiter. You've got this limiter that's enabled by default. And that's the reason I have a limiter on there, obviously, is it's very easy to go over when you're messing, especially when you're dragging this up and down. And this is internally, it's the same limiter algorithm as the loudness limiter. It's just a trimmed down. There's just you can pick true peak or true peak. You've got these basic controls. It just doesn't have, you can't do multiple loudness types simultaneously. And with the loudness limiter, it's if you have multiple enabled simultaneously, it all gets fed through the same ballistics. So it's they're sort of integrated together, and the way the attack and release work, kind of whichever phase of the limiter, whichever loudness type triggered the gain reduction, that will determine the release behavior. So it's got sort of a complicated ballistics. This is a little bit more simplified. And just a note, well, two things. So one thing, when you're switching between these presets, you'll see these two numbers, -14, -1. So the -14 is the average, the center loudness that it's setting. So Spotify loud, it'll pull it up higher. And then the other number, the -1 or the -2 here, that will be the limiter setting. And these ranges are, I got these were listed on this reference website for all these different targets, just as convenience, just to have them there. What was the other thing? Well, I forgot. Oh, when you go to export, actually, the file that it uses, if you disable the limiter and you go crazy and have a bunch of overs, it exports to a 32-bit float wave file format. And in that format, it doesn't care if there's values over 0 dB. So you're not going to lose those. It's not going to clip. And I've tested in a bunch of different DAWs to make sure that they don't clip on the input. And I haven't found one that does. They all seem to just pass it straight through. So generally, if you want to do your own limiting through a different limiter, just disable this one. And when you export, then you have to run it through your DAW or whatever other limiter tool you want to use. But by default, when you switch one of these presets on, it will enable the limiter. I think even if you turn it off, it'll, yeah. All right, well, that's kind of the basics.